Hello. Today we are going to see how to use Docker Init feature for Java programming language. In the past, if you have done containerization for Java applications, you might have seen a Docker file which consists of a multi-stage Docker build. Let's have a quick look at one of the example in the past which I've used on this particular channel to containerize a Spring Boot application. We start with the build stage and starting with the Eclipse Tamarind 17 JDK version of the image, and then we use this copy instructions to copy the POM file, the Maven file, and the Maven directory, the source code as well. And then we use the mount feature to mount the packages or to create a cache for our packages or dependencies as a mount point. And then we run the Maven package command here and we skip the test. And then once the build happens, or once the project has been built, once we have the jar created, then we have a final image which is based on the JRE image or JRE of Java 17, which contains an app folder, and then we copy the output from the previous stage into this. And finally we create expose, or we expose the port on which the application is going to be available, and we create an entry point to start the application. This is a typical multi-stage Docker file required for Java application. Now in this age of AI and automation, it would be better if somebody can create this file for us instead of we going and creating this manually. This is where Docker Init comes into the picture. If we look at the Docker Init documentation on the Docker docs, it talks about having this init command as part of a top level command in Docker, which creates 4 files. One is the Dockerrignore, which is similar to getignore, and it ignores some of the files which are not required for the build context. Then it creates a Docker file, and based on the programming language that is used for building the application, it can automatically create the Docker file for us. These languages which are currently supported include Go, Node, Python, Rust, ASP.NET Core. And on this channel in the past, I've done a video to show how to use Docker Init with a .NET Core application. There is also support for PHP and Java. That is what we are going to look in this video. And then it creates a compose file, and as well as a README file for markdown format, or README file in markdown format. So with one command, we get all these 4 files generated. We don't have to handcraft our Docker file and the compose file. Let's get started and see how exactly we can make use of these features. I'm going to start by creating a new Spring Boot application by using the Spring Boot CLI. Using this Spring Boot new command, I'm creating a new application called as demo Docker Init, and it's going to use a reference of a project from GitHub, and it creates a REST service. Now if I look at the output, or if I look at the contents of this projects folder, we see that there is this demo-docker-init created. Let's go into that particular folder and let's list down the contents. So this is a typical Spring Boot application containing pom.xml. There is a src folder, and it contains Maven W, the Maven wrapper, and license file and other things. One of the limitation, or one of the thing which the Docker Init command supports, or the limitation of a Docker Init command when it comes to Java, is this is suitable for Java applications which uses Maven as the package manager, and it creates Uber jar. If we are using other mechanisms for packaging our application, the current Docker Init support is not suitable for that. So that is why I have selected, or I have used Maven as the package manager here for building this particular application. Now if we go and run this Maven clean and install command, it is going to build our application, and it is going to install the jar locally onto our computer. While this is getting built, or it's already built here, we can also open this in Visual Studio Code. So let's open the whole folder in code by doing this code dot. And if you look at the contents here, we see that under the source main Java example REST service, there is this greeting controller which is created, and there is a greeting class. And under the greeting controller, we can find a mapping, get mapping for greeting. So if we do localhost, and since this will be exposed on port 8080/8080, and then or localhost 8080, and if we had hit the greeting endpoint, we should see hello and then Default, it will give the value as world. If we pass a parameter, whatever as the name, it will show us that name. So let's run this quickly and see if this works fine as expected. In order to see the REST API working and the endpoint working fine, we can run this Spring Boot as an application by using this command mvn spring boot and then run. This will start the Spring Boot application under the embedded Tomcat server. And if we go into our browser and hit that endpoint localhost 8080 and greeting, we see the result as ID as 1 and the content as hello world. So we know that this particular application is working fine. Let's stop this application which is running, and now let's go and implement that Docker Init command. When I run the Docker Init command, it is going to give me this particular description or the notification that it is going to use, or this utility is going to produce the Docerignore file, Dockerfile, compose file, and readme file. It is also identified based on the type of the project, or it has detected that we are using Java. It says here that this is suitable for Java applications that uses Maven and packages as an Uber jar. So that's a confirmation again that we can use this only for this type of application. Then the relative directory where the source code of the application is, this is under the src folder, and we have the Java version which is Java 17, which we want to use in this case. And finally, it is asking us which port is going to be listening on. So I specify 8080 as the port, and in the output we can see that it has created these 4 files. Our Docker files are ready, and it says that we can use this Docker compose up with the -- build flag to build the application and to run the application using the compose file, and then we can access it on localhost 8080. Let's try this. Docker compose up, and then we specify the build flag so that the image is built. While this is getting built, let's have a quick look at the contents of those files which are created. Dockerrignore is a bare minimal Dockerignore file which ignores some of these dot files like the gitignore, .project, .settings, .ps code, and all others. Then if we go on to the Docker file itself, this has the syntax of a Docker file. It also gives us the reference or the links where we can refer to if we need to modify this particular Docker file. And then line number 12 is the actual starting point of this, starting with from. It's using the 17 JDK Jammy image for the, or tag for the Eclipse Tamarind image, and this is named, or this stage is named as deps. Then it goes through creating the copy of the mvnw.mvn, and it creates the mount cache, and finally it also runs the command which will build the application. So in here it's running dependency go offline. This is where it's pulling the dependencies, and in here line number 39 is where it is actually running the build command. So here we can see the package mvnw package dskip test, and then it moves the contents of the target folder into the target/app.jar. And finally, in the extract part, it is going to extract it from the package. It is using the same base image here, and the last stage is to use this as a JRE. And if we compare to the manually created Docker file, here it is also creating a non-privileged user, which is one of the best practice when we create Docker files. It adds that particular user to the final Docker file, and it extracts the contents of this dependencies, Spring Boot loader, snapshot dependencies, and application. And finally, it runs the it creates the entry point. So when we run the Docker image, it is going to use this Java, and then it is going to pass this jar launcher as the parameter to that. Last file, or the other two files, is the compose file, which creates a service with the name as server. Build context is the current context, and the port that we specified at the time of creation of that wizard 8080 is created as a port mapping here. It also has all other helpful comments for us to understand the context, and if you want to make any changes, where we can look for more information as a reference. The last file which is created is the readme.docker.md. This tells us how we are going to start the application or how we are going to run the application. And it also tells us if we have to deploy this to a cloud, we should tag the image, and if we want to build a different platform image, what should be the command that should be run. So overall, I'm pretty happy with what is generated here and what is created as part of that Docker Init command. Let's go back to our terminal and see if the Docker compose up command is fine. In the output, we can see that the image was created fine, where we have this docker.io library, then demo Docker Init server latest image created, which we can verify again if we run the docker images command on the terminal, and we see this image is available locally on our computer. But when we try to run, it's giving exit code 1 here. It's failing. If you look at the error here, it says that could not find the load main class, and it's giving that launch.jar launcher. It is unable to find that. And based on my past experience, I know that this is not working with Java 17 and Spring Boot version that is used in my application, which is 3.1. If we remove that .launch and we just say the entry point is org.springframework.boot.loader.jar launcher. So let me just undo this, and for the reference, let me just comment this line. So I'm going to copy the whole line and I'm going to comment this, and we just remove this .launch part here. Let's save this file and rerun the command, which is docker compose up and build, and let's see what happens. It's going to try to build it again, and now the build process is very fast because we have that mount, or the dependencies are cached. We have the mount point created for those. That is why this image is built extremely fast. I created a video on this in the past, so if you want to learn more about it, you can watch that video. Now this particular step of changing the launcher works fine, and we see that the docker compose up is able to bring up the container image. It's able to run the application. If we go back to our browser and we hit this greeting endpoint again, now it is pointing to the image which is running inside the Docker, and it's giving us the same output. So with that, we can see that the Docker Init command is able to create all those 4 files, especially the Dockerfile and the compose file, and we are able to start the application by making this slight change. In my testing, I found that this Docker Init works with the latest version of Spring Boot. If we use the Spring Initializer, and instead of 3.1 version, if we use the latest version of Spring Boot, then it works fine with the .launch.jar launcher, but with the older version 3.1 it does not work. So hopefully you found this video useful. In case you found it useful, please hit the like button, and on this particular channel I have done many other videos which are related to this topic, so hopefully you will have a look at those as well. If you would like to get notified when the new videos are published, please hit the bell icon and subscribe to my channel. Until next time, code with passion and strive for excellence. Thanks for watching this video.